Hey guys, welcome back to the channel. In this video, we'll be solving this problem called piling up. It is given here. There is a horizontal row of n cubes. The length of each cube is given to you. You need to create a vertical pile of cubes. You have to make a vertical tower or some sort. The new pile should follow these direction. If cube I is on top of cube j, then side length of j has to be greater than or equal to side length of I. Means the cube which is in bottom, that cube's length has to be greater or equal to the length of the cube which is sitting above it. Okay, so when stacking the cubes, you can only pick up either the leftmost or the rightmost cube each time. Print yes if it is possible to stack the cubes, otherwise print no. Let's see an example here. So 1 2 3 8 7, the result is no, because either you can pick 1 or 7. So if you pick 7, you will be left with 1 2 3 8. Then apply the same technique. You can take out 8. You can't take out 8 because 7 is less than 8, right? Your side length has to be greater than equal to the side length of the guy who is sitting above. So if you will take out 7, you can't put 8, you can put 1, but then after that you will be left with 2 3 8, and you can't put either of them on top of 1. That's why the result is no. You can see, after choosing the rightmost element 7, choose the leftmost element 1. After then the choices are 2 and 8, the 2 and 8, the third round 2 and 8, and both of them are greater than 1, right? So that doesn't match with this criteria. So these are both larger than the top block of size 1. That's why it is not possible. Whereas here, if you will see 1 2 3 7 8, just a small change we did. Then what you can do is, out of 1 and 8 you pick 8, then you will be left with 1 2 3 7. So pick 7. Out of 1 and 7 you can only pick 7. 7 can be put on top of 8. Size is valid. Size of j is greater than size of I. Then you will be left with 1 2 3. So 1 or 3 you will choose. Out of 1 or 3 you can choose 3. Then you will be left with 1 and 2. So out of both you can choose 2, then 1. So you will get a vertical pile of cubes. That's the way. So choose blocks from rightmost to left in order to successfully stack the blocks. So 8 was first chosen, 7, then 3, then 2, then 1. So we'll be given a single integer t for test cases, and for each test case we'll get 2 lines. The first line will get the test cases contains n number of cubes, and then second line contains n separated integers denoting the side lengths of each cube in that order. So these are side lengths. So these are the constraint, and you can see the input. Test case is 2, then value of small n is 6. You can see 6 elements, 4 3 2 1 3 4. This is one block, and then again you have n equal to 3 because the test case is 2. 2 test cases, so this becomes your first test case, and this becomes your second test case. So n value is 3, and 1 3 2 is given to you. So in the first test case you can see the output is yes. We can stack the cubes. In the next test case you can see the output is no, we can't do that. So the reason here is, you can see in the first test case you can pick left 4 first. Out of these 2 you can pick left 4, then you will be left with these guys 3 2 1 3 4, then pick the right 4. You can see, then you'll be left with 3 2 1 3. So left 3, then right 3. You'll be left with 4 2 and 1, then left 2 and right 1. So that's how you pile up and make a tower. And say in the second one you can see, out of 1 or 2 you can choose 2, but 3 then you will be having 1 and 3. Both of them are greater than 1 is greater than no. First of all, how you can do the second one? No order gives an appropriate arrangement of vertical cubes. So 3 will always be come after either 1 or 2. So out of 1 and 2, if you will choose 2, then out of 1 and 3, you have to choose 1, and then finally 3 will be remaining and 3 won't sit on top of 1. So that's the problem. Okay, so the answer is no. So we have to make something like this. So you can see that we have to keep ejecting out the elements, right? Elements from the list. So kind of a push pop thing you can you can imagine, and this is a collections question. So let's look at collection python doc. Can we find something which is related to pop push? This dq would be right, we pops the from one end. So this would be a correct way to approach this problem. So I'll be using that. So let me import it for from collections, import dq, not default, take dq, right? Now let's take the inputs first of all. So t, capital T, is equal to integer type input, right? Then we have the value of n, but these are test cases. So for I in range 0 to t, comma t. So every test case we have to take the value of n, no? So let me take n equal to int input. This is the value of n, and let me take the value of input dot split. This is the list, but we all of them are in integer form, so I'll convert into int map, and I'll save it to something d, but we want this in dq form, no? So dq, inside dq you have this whole input, right, which is 43210. So if you won't have dq, if I'll print d, you can see the difference. Let's run the code. So you can't you have to convert into list, because we have used map, no? So 432134132. So this is just a normal list. If I'll use dq and print d, you'll see it becomes a dq, right? Now we can apply the methods here: append left, clear, copy, count, extend left, index, insert. Which is more important is more pop and pop left, right? Because we have to keep on ejecting out the numbers. So let me comment this guy, and for loop in range 0 to n. So what I'm trying to do is I'm running the loop for n time, because it will check for n times. First time it will check for 4 and 4, the next time it will 3 and 3, then so every time you will be remaining with one less, right? So out of these 4, 1 4 will be ejected, so you will be left with 3 2 1 3 4. Then out of these guy 1 4 will be ejected, so you will be left with 3 2 1 3. So every time you are having one less, so that's why n times it will run. So it is starting from 0, so 0 to n minus 1 it will run, so one less. So every time what I'll do is, if so we'll be using this condition, this guy, the side length. If dqs d0 is greater than or equal to, that is what it is, last guy is what, d of -1. So if this is the case, then what it will do, it will let me store in stack, some stack variable, it will append. So I'll take out the element and store it into some other variable. Okay, so d dot pop, so pop left means left guy will be removed. What it is doing is, if out of this guy and this guy, whichever is greater or equal to, it will take the this guy first, the leftmost guy, and store it into stack. Let me initialize stack here. Why I am initializing stack here every time? Because for the next test case I'll need a new fresh stack, right, not left. Similar thing I'll do for pop. From the right side also we have to take out, no? So if this is let me do greater than, but this here it is -1 and here it is 0, then stack dot append pop. If the last guy is greater or equal to, then it will pop. Not equal to, I will keep like this, greater than, right? Equal to will be in both cases, then it will be a problem. So I'm keeping it in stack. Let's see this, how it looks like. So print stack. Okay, dq index out of range, it is connected plus this has to be else if, okay, greater than d0, I think this is correct. Yeah, so you can see this is your stack now for 4 4 3 3 2 1 2 3 1. So 2 has been taken first, and out of 1 3 1 was taken, and then 3 was taken. Now what I'll do is, I'll have these guy and I'll compare it with sorted one. Okay, we have stack. Let me show you sorted stack. Sorted stack, how it will look. So you have stack here, then you have sorted stack here, 1 2 3 3 4 4, and you have this stack and sorted stack 1 2 3. But we want this in reverse fashion, so let me do reverse equal to true. So you can see it will be reversed. Reverse. So what I'll do here is, you can see this guy is stack and this is its reversed form. So they both look equal, right? So which is yes for us. And then when you have this stack, test case 2, and the sorted one, you can see they both are not equal. And that's the sign you decide whether it is pileable or not. So if you'll have the sorted one equal to this guy, the normal one, then you will say yes, you can pile up. But if you don't have the normal one with the sorted one equal, then you will say no, you can't stack it, right? You can see because only in this case, only when you will have in the sequence a decreasing sequence, then and then only you will be able to keep one cube on top of the other. So fourth guy first ejected out, so fourth will be in bottom, then above this 4 will be there, above this 3 will be there, 3, then 2, then 1. So this follows this condition, right, perfectly. But when you will have the second case, you can see second guy will be there first, then out of 3 and 2, 1 will be there, then 3. There is no sequence, right? That's what written here. There is no arrangement appropriate, no order gives an appropriate arrangement. So if you will have 3 2 1, this is the appropriate order. 3 should be in the bottom, then above that 2 will be there, and then above that 1 should be there. But you are not having this case when you are dealing with second test case. So in that way, these two guys will not match, and hence you will be having no as an answer. So let me do that. Let me write an if condition. If stack is equal to sorted stack, which is this guy, then what you have to do is print yes, else print no. No, right? Simple. So now you're having everything, yes and no. Now let me comment these guys. So we don't want this as well as this, we want only yes or no, and this is working for all test cases. So yes and no, yeah, correct. Let's submit this. All the test cases are passed and we are done. Okay, so let's move on to the next problem now.